Alrighty. So section 1.1, it talks basic concepts of math. So we're going to talk about what a variable is, what a constant is, how to plot some point, and some inequalities, right? So if we put a number line here, and if we're in the classroom, I would draw it on the board. So we have our little number line, and then I started, and I have the numbers already on here, right? So typically on a number line, 0 is right in the middle, and then to the right of 0 are our positive numbers. So 1, 2, 3, 4, 5, I have them in red. And to the left of 0 is our negative numbers, -1, 2, 3, -4, -5, right? So now we're going to go in kind of some definitions. A natural number, right, is what also called a counting number. It's how we count. So think when you're little, if we have little brothers and sisters, or if you even have little kids, right? When we start counting, we start with our fingers, 1, 2, 3, 4, 5. Those are natural numbers. That's how we naturally count. A whole number is all the natural numbers plus the number 0. So the only difference between a natural number and a whole numbers are all the natural numbers plus the number 0. All right, and I got this written, typed out here as well. Then there is some whole numbers and natural numbers that are called prime numbers, right? And a prime number is any number that is only has the factors itself and 1. So I listed some of the prime numbers here. We have, 2 being the only even prime number. And the reason 2 is the only even prime number is because 2 can go in any even number. So once you get past 2, every even number has a factor of 2. So 2 is the only even prime number. And then we start rattling off some of the other primes. So 3, the only number that goes into 3 is 3 and 1. 5, only factors of 5 are 1 and 5. Then 7, 11, 13, 17, 19, 23. What's the next one? 29, 31, 37. Right? So it goes on forever. That's what these 3 dots mean, right? I actually typed in 4 dots, but this means they can go on forever. So, but that knowing what a prime number is lets us know when we have simplified something all the way down, right? So that's why prime numbers are beneficial. And then you might have heard of this in other math classes called prime factorization. So that's what you do is you take a number and you list its factors out until all you have left is prime factors. So an integer is positive and negative numbers. So if we look back at our number line here, right? -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Those are all integers. So integers are positive and negative natural numbers, as well as the number 0. And the reason to know these definitions is because when we get into more advanced stuff, some of the rules are going to say you can only use these type of numbers. And if you know what they are, then it makes it a little bit easier to solve. All right, so we're not going to, obviously in the classroom, so I'm not going to draw it out because I've already drawn it out. Make this a little bit neater here. So a rational number is any number that can be written as a fraction or a decimal, right? So if I can write a number as a fraction, then that is a rational number. And so if we go back to our natural numbers, right, the number 5, oops, that's not what I want. The number 5 is a natural number, and I can take any number and I can put it over 1. And so since I can put 5 over 1, that therefore I made it a fraction. 5 is also a rational number, right? 1/2 is a fraction, so that is also a rational number. 0.25 is not a fraction, right? But I can turn it into a fraction by taking the number and writing it as a natural number, 25, and then putting it over 1, and then counting decimal places, right? If I move the decimal place 1, 2 places, I add 2 zeros, and now I've taken 0.25 and turned it into a fraction So 0.25 is also a rational number. So any number that you can turn into a fraction is a rational number. Irrational numbers are everything else. So I have two examples here. Square root of 2 over 3, right? Oh, I guess I should correct myself, sorry. A rational number is any number that you can write as a fraction where they are integers. That's the key piece I forgot to mention. So again, why we need to know our definitions, right? We have to know what an integer is. 5 is an integer, 1 is an integer, 25 is an integer, 100 is an integer. A rational number, even though it can be written as a fraction, the square root of 2 is not an integer, so therefore this is an irrational number. Pi, the symbol of 3.14, goes on forever, so therefore it is not an integer, and therefore that is still an irrational number. So if our fractions have these weird things in them, then that's a good sign that they are irrational. And then there is the special cases, right? Like, so 1/3 is, when you put that in decimal form, is 0.3333 repeating, right? So even though it goes on forever, I can write that as a fraction, 1 over 3, both are integers. So therefore 1/3 or 0.3 repeating is also a rational number. Any questions about what numbers are? And again, the big takeaway for this is just to talk about things when we get into other, like probability, and we say, you know, probabilities can only be positive rational numbers. We have to know what positive and rational mean, right? So that's kind of the importance of this first part of this chapter. All right, so no questions. We'll go into how we graph. So I got a little table here, and I put a plane, graph and paper plane on here. And so typically our book uses different letters. It really doesn't matter what letters you use, but I'm going to default to the ones that most of you have seen just to keep things comfortable. So typically our y-axis is our vertical or up and down axis, and x is typically our horizontal, right? In algebra, we make it sound like that's the only way it can be. It cannot. It can be anything you want it to be. In the book, I think they use N and A. And when we get more into statistics, we're actually, instead of using letters, we're going to put words there. So it doesn't matter. The key is knowing which axis represents what, right? So in this case, I made this X and Y because that's how most of you have seen it before, just to get us comfortable with it. But as we get further in the course, X and Y will disappear and we'll start using other terms and symbols. And then as we look at the planes, they are broken down in quadrants. So this first one here is quadrant 1. And then we do this counterclockwise, which goes opposite of a clock. So count quadrant 2, then quadrant 3, and then finally quadrant 4. And knowing the quadrants will help make sure you plot correctly, right? Because in quadrant 1, everything is positive, right? So if we look things as a point, there's a parentheses. So the first value is positive, comma, the second value is positive. So in quadrant 1, both the numbers are positive. In quadrant 2, the first number is negative, the second number is positive. In quadrant 3, they're both negative. And then quadrant 4, the first number is positive, the second number is negative, right? And because we're in 2 dimensions, that's why we have 2 values. If we want to go into 3 dimensions, then we would have 3 values. We do not plot 3 dimensions in this course, but just so you know, there you can do 3 dimensions, sorry. Precision machining, if you're going to get a degree in precision machining, you'll do a lot in 3 dimensions. The other piece I want to talk about is where these 2 axes cross. That is called the origin, and that is the point 0, 0, unless labeled otherwise. Right, so if there's no label, we will assume it to be the center of 0 and 0. And the reason for that is that it follows a number line, right? If I go to the origin and I look to the right of it, those are positive numbers. If I go to the origin and look to the left of it, those are negative numbers. For my vertical axis, I go to the origin. If I go up, that represents positive. If I go down, that represents negative. So that lines up to our quadrant system, as well as the values that I've put in the parentheses. All right, so I've labeled my points A, B, C, and D just to make it a little bit neater. So if I go to plot point A, I come to the origin, and you can see I say X is 2. So I go to the origin, and I count over 2 spots, 1, 2. And then Y is 3, that's positive, so then I go up 3, 1, 2, 3. And there is point A. So point A is in quadrant 1. Now I go to point B. I always go to the middle just to make sure I don't count wrong. I got a -1, so that means I go left 1. And then I have a +4, so I go up 1, 2, 3, 4. And there is my point B in quadrant 2. Come to my origin. All right, so I got C. And it says -5, so I'll go left 5 spaces, 1, 2, 3, 4, 5, and then down 7, 1, 2, 3, 4, 5, 6, 7. Oops, it's supposed to be a point, not a line. Clean that up. I'm gonna do it again. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Point. There we go. And there is the point C. And lastly, D. I have a +6, so that goes to the right 6. 1, 2, 3, 4, 5, 6. And then down 8. 1, 2, 3, 4, 5, 6, 7, and 8. And there is our final point, point D. Any questions on how we graph? Okay. Inequalities. So inequalities are these symbols that I put in this table. It talks about them more in detail in the book, but we'll still mention them. So the way I like to think of it, depending on your age, I always think of it as Pac-Man. Some people say alligators, but it looks like a mouth, right? And the wide opening goes for the bigger side because it wants to eat the most, and the smaller side does not. So there's a funny thing that kids like to remember when they're younger, and I still remember it all these years later. But when I have the symbol that looks like this is called the less than symbol. So an example of less than, right? We'll draw it out here. 2 is less than 5, right? 2 is smaller than 5. The next one is less than or equal to. So I can say the same numbers. 2 is also less than or equal to 5, right? But I could also do 5 is less than or equal to 5, right? Both of those are true statements because 2 is less than 5 and 5 is equal to 5. So I can do it. Either one of those are true for my less than or equal to. And see, the difference is less than does not have the line under it. Less than with a line under it is less than or equal to. Then we have our good friend, the equal sign, right? So 5 equals 5. That's one we're pretty much comfortable with. It's not really inequality, but I still like to include it in the table just to see where it falls into the system. Then we have not equal to is just an equal sign with a slash through it, right? So 2 does not equal 5. Now greater than, right? I can say 10 is greater than 5. And then lastly, our greater than or equal to 10 is also greater than or equal to 5. As well as I can do like we did before, 10 is also greater than or equal to 10. So just remember the opening always goes to the larger number. And where you have to be careful with is when you have negative numbers. So when you're going negative, the number is actually going to be bigger, but the sign makes it smaller. So like, for example, -6 is less than -2. right? So 6 is bigger than 2, but because it's negative, it means we're going left on the number line, and therefore the negative sign, it means it's further from 0, so therefore it is smaller. We're talking about how far from 0 things are on the number line. So there's a quick run through there of section 1.1 of what our numbers are, how to plot, and such. So some of the problems, I guess we can go back up here to the number line, right? If I create a number line, actually we'll do that at the end. We'll wrap all this back up at the end. So we'll come back to that in a minute. 1.2 is expressions. So all an expression is a combination, well, I guess before we get to expressions, let's talk about what a variable is. A variable is a symbol, typically a letter, and right, in algebra, the common letter that we like to use is the letter X. So we got to get out of the habit of using X for times, because now that we're getting into algebra and statistics, X is going to represent something other than time. So stop. I highly encourage you to stop using X to mean multiplication. Either use a dot, a star, put the things next to each other in parenthesis form if they're numbers, or if it's just a number and a letter, you can write them next to each other. All of those represent multiplication. Okay. So that is what a variable is, and it represents an unknown number or number. So variables still have to follow the rules of numbers, right? Just because it's a letter doesn't mean it gets new rules. And I think that's where people struggle with algebra, is they think this is something, it's totally different. It's not. It's just a placeholder. It's just say, hey, hold the spot for me until I know what you are, but you still got to follow the rules. So it is just an unknown number or numbers. An expression is a combination of variables and constants, and all a constant is a number. So that's what it means. So an expression is a combination of numbers and variables, right? And every time you add or subtract things in an expression, each individual thing is called a term. So when I have, bring back up my draw. If I have 4x plus 5, right? I have my variable is x, my constant is 5 and 4, because those are my numbers. So, but this is considered to have two terms because terms are separated by a plus or minus. And this is an expression, and really all an expression is basically an equation without an equal sign. Notice there is no equal sign here. Since there's no equal sign here, I cannot actually solve the problem, right? If I solve it, that has an equal sign. Right now, all I can do is simplify the problem, and that's what 1.2 does, is how we simplify expressions. Basically, we're going to move things around, but we can never actually solve it. You can only solve things that have an equal sign, or an inequality. We can solve inequalities, even though we don't get to that in this course per se. So we can, though, even though we're not solving it, we can evaluate an expression if someone tells us what the variable is, right? And we'll get to that here in a minute. We can do one, I guess. What if I say x equals 2, right? Then all I need to do is I put 2 where x is. So this becomes 4. And I always put I put parentheses to represent times because I don't want to use x anymore. So 4 parentheses 2 plus 5. All right, so 4 times 2 is 8. 8 plus 5 equals 13. So I can, if I am told what the variable represents, I can solve the expression. I don't want to interrupt class here, but if the two of you can remind me before we end to talk calculators, I did forget to talk about calculators, all right? We can use them, so I'm going to give you some pointers of which ones I think you should use. So just please remind me before we go to talk about calculators. So adding and subtracting algebraic expressions, it means you can only combine terms if they're exactly the same, right? They have to have the same variable. They also have to have the same exponent. So I have a example here. This is a 3-term problem because I have g t squared minus 2vt plus 2s, right? So looks pretty ugly, right? Because I have multiple variables in it, but it's fine. I can't combine any of these things because each one of them is different. Just like the 4x plus 5 is 2 terms, I cannot combine the 4x and the 5 together to make 9x because the 5 does not have an x. So to combine expressions, they have to have the same variable. They must have the same letter. And since 5 does not have an x, you cannot combine them. If I'm going too fast, tell me to slow down too. Factors mean the products of a number. Polynomial is an algebraic expression with non-negative integer exponents and one or more variables. All right, so what I have up top is considered a polynomial because it has 3 terms. It would actually be called a trinomial. 4x plus 5 is a polynomial because it has 2 terms, and this one could be called a binomial. And a monomial is just something that has more an algebraic expression of, well, multinomial, sorry, expression of more than 1 term. So this one's a little trickier than what's in the book, but if you can follow along with this problem, then you are allowed to solve the ones where we're going to have in this course. Sorry. So when we had, this is a tough one. That's why we're going to do it as a class. It has a subtraction sign in here, and it has parentheses, right? So to do that, we need to distribute the negative sign through to remove the parentheses. So you can see, I'll write over here, even though I already have the answer for you to see. I rewrite this, so I have 5x squared minus 4y plus 2w. And now I'm going to distribute this negative sign, which basically means I change the signs of everything that's inside. So then this becomes minus 2x squared plus 3y, because 2 negatives become a positive, and then negative and a negative with a w comes a positive w. And then what I need to do is I need to go through and combine everything that's exactly the same. So he has an x squared, he has an x squared, so I can put those two together. So 5x squared minus 2x squared. And then I'll circle them now. He has a y, he has a y, so minus 4y plus 3y. And lastly, I'll put the lines above. I can bring my w's together, plus 2w plus a w. And what allows me to do this is the commutative property. The commutative property allows me to move things around. And now I can combine these terms, and when I combine things, the variables do not change. So 5x squared minus 2x squared, the x squared stays the same, and only the numbers in front change. So 5 minus 2 is 3. My y's, negative 4 plus 3. Remember, when the signs are different and we're adding, we basically subtract. So 4 minus 3 is 1. And then I keep the sign of the bigger number, so this becomes a negative 1y. However, we don't need to write the 1 there, so it just becomes negative y. And then 2w plus, that's supposed to be a 3. I didn't realize I made it so ugly. 3. 2w plus 3w becomes a 5w. All right, so this one had a lot in it, but if you follow along and you understand why I did what I did, then a lot of the problems in the book should be a little bit easier because with not many exponents and not many double variable problems. So any questions on adding or subtracting expressions? All right, so multiplying algebraic expressions. You may have heard of foiling, right? Where FOIL was first, outer, inner, last. And so I have written out the formula here of how it works. But to get an example here, if I have x plus 2 squared right? All the squared means is I am multiplying what's inside the parentheses by itself. So then this becomes x plus 2 times x plus 2, right? And now what do? Is I multiply the first two together, so I'm going to put letters above them. So here's the first, and here's the first. So x times x, which is x squared. And then I do the outers. So he is an outer. He is an outer. So that becomes a plus 2x. And then I do my inners. So this is my inner number. This is my inner number. So again, a plus 2x. And then I get to do my last numbers. So there's my last, and there's my last. And 2 times 2 is 4. And then what will typically happen when we FOIL is we have to combine terms, because you notice there's only one x squared, so that's just x squared. But I do have a plus 2x and a plus 2x, so that becomes a positive 4x. And then I bring down my plus 4. And I can't do anything else because even though I have two x's, one of them is x squared, and I can't put an x squared with just an x when I'm adding or subtracting. So that's as far as I can go. Any questions? Okay. So what if I tell you that x equals -2? So then what you do is you come over here and you put -2 everywhere x is. So I put -2 here. Remember, it is squared. What you'll have to do, and there's a reason I picked this number so we can test our calculators, you need to put this in parentheses. If you do not put it in parentheses, you're not going to get the right answer. So -2 squared plus 4 times -2 plus 4, right? So if you get your calculator out, you can actually just do this in your calculator. I will do it by hand just so we can see it. But I do encourage you to practice this problem on your calculator to make sure that you know how to put it into your calculator correctly. Because that negative has to be in parentheses. If you do not put that negative inside parentheses in your calculator is actually not going to square it right. So -2 squared is a positive 4, because -2 times -2 is positive 4. And then 4 times -2 is a -8. And then plus 4, right? So 4 minus 8 is -4. Then plus 4, this whole thing just equals 0. So when you go to solve this on your calculator, if you're not getting 0, then you're typing something wrong in your calculator, right? Because -2 will give you the value of 0. And the reason I caution people with their calculators with these negatives is because if I have -2 squared, what this really means, this means -1 times 2 times 2, which is -4. So if you put -2 squared in your calculator later thinks you want -1 times 2 times 2, because the squared is only on the 2 and it is not on the negative sign. If I have it in parentheses, well, then that does equal -2, from my squared, -2 times a -2, and that does equal positive 4. Right, so it's careful how we say things and what we're doing. And this is going to be important when we get into statistics, because a formula is going to have all these symbols and all these ways to put the numbers in. And if you don't put the numbers into the formulas correctly, then you're going to get the wrong answer and you're not going to understand why. And it's not because you picked the wrong formula, it's you are doing the wrong arithmetic. So it's extremely important that you have a good calculator. And I am not a fan of cell phones. I don't care if you use them, but I find more often than not, people that use their cell phone calculators get the wrong answer, especially in statistics. So I highly encourage you to get a calculator. And again, I will talk about those near the end of class, show you which ones I recommend. If we're dividing expressions, so here we divide no, I don't need that piece. Let me take that out. That's for a different class. We don't do that here. So escape, so I don't confuse you when you come to download these notes. delete. So if I have 4x minus 5 all over x, I can rewrite that because it has a common denominator and break my fraction apart to be 4x minus 5x, right? And so if I do that, I get 4x minus all over x minus 5 over x, right? And in this case, these two x's cancel each other out. So all I'm left with is the 4, and then I bring down the minus 5x. And again, I can't combine these because one has an x and one does not. So that's as far as I can go. However, if I know x is equal to 10, I can rewrite this as 4 minus 5 over 10, right? 5 over 10 reduces to 1/2, so this just becomes 4 minus 1/2, which equals 3 and 1/2 as a mixed number. So if I know what x is, I can actually solve the problem. If I don't know what x is, there's nothing I can do. And this is a perfect problem because it takes us into the last section that I want to talk about today, is operations with fractions, proportions, and converting units. And what I'm gonna probably do today is we're gonna just do fractions because I feel like I'm going quick and I want to kind of give everybody some time to catch up this week. And then we'll go into proportions and converting units in next week's lesson. So a little bit more to go today, and then we'll take a break and I can answer questions. So fractions. I already know the majority of you don't like fractions. The reason I know that is I've been teaching for a while, and most of my students just tell me they just don't like fractions. Unfortunately, in statistics, if I can speak, we're going to do a lot with fractions because probability, proportions, percentages are all part of statistics, and those are always written as either decimals with a percent symbol or as a fraction. So we are going to have to work with fractions in this course because that is just the rules of fractions. And I'm not going to spend a lot of time about fractions because I think most of you have seen them before, so you know what a fraction is. You just don't like working with them, and then I can assist in that piece. So we're going to talk about some terms here for fractions. So principle of fractions, all right, the value of the fraction is unchanged if both the numerator and denominator are multiplied or divided by the same non-zero number, right? So this is how we simplify fractions, right? Or how we find a common denominator when we add and subtract. Stuff that you've done before. You might, like I said, might be rusty, but you do know it. And we always want to get our fraction down to the simplest form, which is basically we want to get it down to where the numbers don't have any common factors or any common prime numbers. And so this is done by what we call reducing, right? So here I have an example. So if I have 12 over 36, right? Both of these numbers, 6 can go into, right? So 12, and this is where it says where I can unchanged if I am multiplied or divided by the same thing. So if I divide this by 6, and I divide this by 6, right? Because I'm dividing it by both the same numbers, so that means it doesn't change the fraction. Well, 12 divided by 6 is equal to 2. 36 divided by 6 is equal to 6. And I am at now 2 over 6. Well, these are still both even, which means that I can also divide it again both by 2, which then gives me the answer of 1/3. And now I am down to a prime number 3, which cannot go into 1. So therefore, I know this is as far as I can reduce this problem. And some of you might have looked at this and said, well, 12 over 36, I could have just divided both by 12 and been done with this problem in one step. You're exactly correct, right? So if you know your factors well, then yes, it is. You can simplify fractions quicker. If not, I mean, start with the ones you do know, right? I know that 2 can go in any even number, so maybe I start just dividing this thing by 2. So what are some of the rules of fractions, just to refresh, right? So if I can take any number over 1 and it doesn't change its value. So a over 1 just equals a, right? Anything over 1 just is itself. When I have the same numerator and the same denominator, so a over a, well, that just equals 1, right? And that takes us back to this whole point of why I can do the things I'm doing up top. If I do 0 divided by a, can I have 0 in the numerator? And I only have a few of you today, so I don't think you're going to answer. But yes, you can have 0 in the numerator. 0 divided by a is 0. What I cannot do is I cannot divide by 0. So this does not work. This is no. You cannot divide by 0. And the reason, a little problem I like to think about, explain this non-mathematically, right, is what we call the cake problem. If I have no cake, so there's my 0, and I want to divide it with everybody in the class, how much cake do you get? You get none. I have no cake to give you, right? So that is why it's okay to have 0 in the numerator, because I can take something and I can divide it among everybody. Everybody gets the same thing. Nothing, 0. However, if I have cake, I can't divide it into no parts. I can't break it up to nothing, because that means the cake disappears. All right. So unless you know magic or a magician sleight of the hand, you can't just make it disappear. So therefore, it is a non-mathematical explanation why we don't divide by 0. Right. So I can take something and divide it into pieces, and everybody gets the same thing, nothing. But I can't take something and divide it into no pieces because it's there. It exists. My computer kind of shrunk this down when I put it into form, but 1 3/4 is called a mixed number, right? So what does this mean? So it means one whole. So I can draw a circle. So this whole thing, I got a whole of something, a whole cake, if we want to stick to our cake theme. Or since we're drawing circles, we can say pizza. And then I have 3/4 of another one. So that's what a mixed number is, right? So 1 3/4, you have a integer in the front, and then next to it is a fraction. This is called a mixed number. We can even type this in here. So let me go home, hit escape, and go right over here. This is called a mixed number, right? We'll put that right there. Mixed number. 9/2, this is called an improper fraction. And for some reason, when we first learn fractions, we're taught that this is not a good thing. However, in algebra and statistics and analysis that I use, I prefer improper fractions over mixed. So improper fractions are okay. All it means to be improper is that the numerator is larger than the denominator versus the fractions that we were dealing with before. The denominator was smaller than the numerator. And the key why I like improper fractions is once I have things improper, multiplying, dividing, adding, and subtract, they are much easier to do as improper fractions than they are as mixed. And so I can take a improper fraction and make it into a mixed number by doing long division. So if I take the denominator, 2, and I divide that into 9, all right, so little refresher of our long division. 2 can go into 9 4 times, because 2 times 4 is 8. I subtract, I have a 1. This number is smaller than my denominator, so that's called my remainder. So if I put this as a mixed number, this becomes 4 1/2. So that's how I can convert the other way. If I want to go improper, then I take the whole number, I multiply it by the denominator. So 4 times 2 is 8. And then I add the numerator, which is 9. The denominator doesn't change. And now I'm back to my improper fraction. So that's how you go between a mixed and an improper, by following those two rules if you need to convert anything. Any questions on what fractions are? All right, so let's talk about the rules of fractions. All right, so when we multiply and divide fractions, in my opinion, those are easier because then I don't have to worry about any crazy rules. I just literally multiply or divide, right? So if I am multiplying 1/2 times 3/4, so 1/2 times 3/4. So my little dot or star, or whatever you want to draw. And so what you do when you multiply fractions is you multiply straight across. 1 times 3 is 3. 2 times 4 is 8. So there is our answer, 3/8. If we divide the fractions, so if I do 1/2 divided by 3/4, well, you rewrite it. So you keep the first fraction, you change the divide into a multiply, and then you flip the second fraction. So I go from 3/4 to 4/3, and now I am multiplying. So I just multiply straight across. 1 times 4 is 4. 2 times 3 is 6. And because these are both even, I divide by 2, and I reduce down to 2/3. When you add and subtract, you must have a common denominator. The number in the bottom must be the same, right? So a little math trick, right? All even numbers have a factor of 2. If the product sums to 9, then the number has a factor of 9. And since therefore it has a factor of 9, it also has a factor of 3. If a number ends in 5 or 0, then it has a factor of 5. So there are some quick ways to find a common denominator. The long way is just multiplying the two numbers together, which is not wrong. It just means you have to do more simplification at the end. So our last two examples for the day, if I have 2/3 plus 1/2, I need to come up with a common denominator. So what is a number that both 3 and 2 can go into is 6. So what I like to do is once I know my common denominator, I just put that as my denominator. I know that's what it has to be, right? And I'm adding, so I put a plus. Well, how did I go from 3 to 6? I multiplied it by 2, right? Well, if I multiply the bottom by 2, I have to multiply the top by 2. So 2 times 2 is 4. To go from 2 to 6, I had to multiply it by 3. And well, what I do the bottom, I have to do the top. So 1 times 3 is 3. And then when I add the fractions, I don't change the denominator. So that stays a 6. And then 4 plus 3 is 7. So the answer is 7/6. It is an improper fraction, but I can stop there because 7 is prime. 6 can't go into 7, so therefore I can't simplify it. And so that is the final answer. Now, if you want to make it mixed, that is completely up to you. I am okay with the answers being as improper fractions. And then the last one we'll do today is a subtraction problem. So if I have 2/3 minus 1/2, again, I have to have a common denominator. So I purposely picked the same numbers so that we can just quickly convert them. So it would be 4/6 minus 3/6. Again, I don't change the denominator. And then 4 minus 3 is 1. So I have 1/6. Any questions up to that point? So not quite where the syllabus says we are, but I think we've covered a lot today. So we will start next week with proportions and unit conversions. Questions? Okay, so two calculators that I recommend because of pricing, nothing more. I like the Casio FX 300 ES Plus. It is a very inexpensive calculator. Can you guys see the calculator on the screen right now? You can either comment or just quickly say yes, just to make sure you see what I see. Yes, thank you. So this one, I think it was like $8 when I bought it a couple years ago. It might be up to like 10 or 11. Walmart has it. It's the Casio FX 300 ES Plus. I like this calculator because it has a fraction key, right? Let me bring up my little annotate so you can kind of see it. So this key right, I don't want blue, black because the thing was already black. We'll go light blue. Right there, this key right here, that is how you put in fractions on that calculator. And why I like it is when you use that key, it looks just like it does on the paper, right? So there's your fraction key, you have a square root key, you have the squared key, and then you have a key to put in exponents, right? And there's also this key down here that says NPR and NCR in yellow. You will need those keys in probability and statistics. So this calculator will get you to your next math class. This calculator actually will get through every math class you would have to take in college. This is a really good calculator for the price. You don't need fancy graphing calculators, $100 calculators. If you have them, great. You may use them. I'm not going to say you can't, but this is a nice cheap calculator that will get you through algebra, statistics, and even calculus, right? So those are kind of the key things that we need. If you take algebra, then you'll use all these keys over here. So it has everything you need. Another key that I like on this calculator, why I recommend it, right? Because we use calculators, so you don't need to do any things by hand. I'm not going to ever take your calculator away, right? You get a calculator in the real world, you get a calculator in this class. But what key that I really like on this calculator, I gotta bring back my annotate here. There it is, draw. Okay, come on, there we go. Is this SD key. That switches between decimal and fraction. So it's a quick conversion. So for you all that just really, really don't like fractions, get a calculator, learn how to use the fraction key instead of the divide key. Don't use that key for fractions. It's always going to turn into a decimal. Use the fraction key. Your calculator will simplify and solve fractions for you. So very good calculator. This calculator ranges somewhere to $8 to $20, depending on where you buy it, right? Another one that I like, that is one I started with, and this is the one that's sold in the bookstore, is the Texas TI 30X, I think. Yes. And you can see I went to Target, not even by accident, purpose. I just clicked on images, basically. Let me clear my drawings here real quick. So this is another one. This is the one they sell in the bookstore. I think the bookstore they sell for like 22 bucks. This is another good calculator, and this is kind of the one I actually started with. So let me see. We'll pick another good, easy color to see. Green seems to work good on this background. So this ABC key right here, I guess green doesn't work as well as I thought. That is your fraction key. So if you use that key, that puts your calculator in fraction form. Again, don't use the division key. It's not wrong, but you do it. If you hit the second key, and then this FD probability key, you see ED. This is how you go from fraction to decimal. The probability key right there below it is how you do probability. So that's one key that you use a lot in statistics. It does have statistics in here under data, and you can see it says stat right there. So this is a great calculator for statistics. Again, it has all your keys that you need right in the middle for college algebra and calculus. I'm not saying you're going to get there, but again, this is one calculator that you can buy that will get you through all of your math as well, and it's not too bad. So you can see Target sells it. It looks like for $16.79. Again, the bookstore has it for like 22. I think Walmart sells it for like 18. So both of these calculators are less than 20 bucks. They're ones I know how to use really well, so I can help you. If you have another kind, don't go buy a new one. My best advice to calculators: just make sure you know how to use it. Very often I have students just go buy the most expensive calculator so they think it can do a lot for them, but then they have no idea how to use it, and it does you no good if you can't use it. So whatever calculator you decide to get, look it up on YouTube, ask me. I pretty much know how to navigate every calculator and I can assist you, but don't keep doing things by pen and paper. You can if you want. I'm not going to tell you you can't, but when we get into some statistics, it's going to be extremely challenging. And you want to get comfortable with your calculator before you take the test. So use that calculator on the homework, because if you can solve the homework problems using your calculator, then when we go to take the test, you know how to use your calculator. So there is my recommendations for calculators for this class.